Rob?
All right, Jennifer, thank you very much. It is 7:25, time for part 2 of our Chemist Corner segment. Our resident chemist is back, Jesse Miller from the U of I. And we got a pretty cool experiment. Now, we've been building this up for about 25 minutes here. So.
That's right. Well, first, we'll do a smaller one that the kids can do at home.
More build-up.
That's right. We'll do a smaller one the kids can do at home. We actually do this when we go out to the schools and do some of the Family Nights programs and some of the third-grade programs. This is one of the ones we have them play with. Okay. And this is another surface tension. We actually just got a couple of things. There's some surface tension and the fact that milk has fat in it. Sure. Whole milk has more fat. 2% only has 2% fat, and it's homogenized, so all that's mixed up into there. It's all one solution. Right. Yeah. I need the soap, and I need soap. There we go. And so what we're going to do here?
Pour a little milk in this dish.
Pour a little milk in the dish just to cover the bottom. Put a couple of drops of food coloring here on top, just to
stayed right where you put it.
Yeah, it stayed because oil and water don't mix, right? There's a lot of fat in milk. Sure. All right, so now, as I said, this is a surfactant, okay? And the soap is going to break the surface tension up. It's also going to free the fat and the milk to move around. And because it's charged on one side and the other, it's just going to kind of chase itself around here. And you'll see something interesting here.
Whoa.
Okay, you can put a couple of drops here, and after it sits for a while, and as you can see, it starts roiling. You can get some really interesting looking patterns out of it, and you can use different colors.
Sure. It's kind of like a lava milk lamp.
Hey, there you go. We're working on a theme. I'll have to say
hours of enjoyment, right? I could watch this for hours. That's very cool.
Yeah, it is. It's really neat. All right, so now here's the big finish, right?
Okay.
So we use salt on the roads and stuff like that.
Of course.
Sometimes we use sodium chloride, sometimes we use calcium chloride. There's some other things. Calcium chloride is not nearly as harmful to the environment as the sodium chloride is. And the way that works is that it lowers the freezing point of the water. It's called a colligative property of water. It lowers the freezing point, so the more stuff you have in the water, the lower the temperature is. So when they put the salt on the ice, it lowers the freezing temperature, and actually you can get it down to, it's about 20 degrees Fahrenheit. Wow. Below that, then it just stays frozen. Okay. So what I've done here is I've taken some ice and put it in here, and I've put some salt, just table salt in here, and I've got this down to about -7 degrees Celsius. Okay. Okay, now, this is a Schweppes bottle. This is just club soda, and we've been cooling it in this ice bath here for a while.
Actual bottle, too. It's not plastic.
Oh, no, it's not plastic.
It's a real bottle.
So we've been cooling this down here, and the reason why this isn't frozen is there's a couple of reasons. One, it's under pressure. Okay. Okay, and as you lower the pressure, you also lower the freezing point as well. So the pressure keeps it from freezing, and another reason is there's carbon dioxide that's trapped inside there, right? It's club soda. Sure. And that also lowers the freezing point. Okay. Okay, now what we're going to see, it's mostly supercooled. And so it's ready to freeze at any time. If we crack this open, okay, you should just see it instantly freeze.
Instant freeze, huh?
It's going to be instant. If you want to do it.
Yeah, we'll get the shot set up. Al, you give me the go-ahead whenever we're ready.
Let's see, this one's already starting to freeze. So.
Okay. Ready, Al? Yeah.
Okay, and there it goes.
Wow. That's a pretty cool parlor trick.
It is. It just goes right down. I want to make sure that. There we go. We relieve the pressure on that. And it just zips right on down there. We'll just go ahead and do the other one, too.
Yeah, there you go. That is very cool.
Yeah, there you go.
Awesome.
There you go, the colligative properties of water.
Awesome. Well, great experiments today, Jesse Miller. Thank you very much. We appreciate your time. We'll put this on our website, IllinoisHomepage.net. Look under the morning show. And look under Chemist Corner. We'll get you a new fancy thing you can click on, and everybody can watch these. And kids, you can try these at home. And this milk, green blue milk, still producing stuff down here.
Oh, yeah, it'll go for a long time.
Awesome. I have stuff to do the rest of the day. All right.